Welcome to the deep dive. We've got a really compelling stack of sources today,
Yeah.
articles, research, some of your notes, all centered on this incredible, almost breakneck speed of change in artificial intelligence. So our mission today is to unpack these together, pull out the key insights, and, well, give you a shortcut to being genuinely informed about what really feels like an unprecedented moment.
Absolutely. And the data you've pulled together, it offers such a powerful look at just how fast AI is evolving and, across so many different areas at once. It's really about looking at the patterns in those numbers, the charts, and understanding the bigger picture they're painting for us.
Okay, perfect. Let's get into this stack and dive right in. So the first big question, I think, right out of the gate based on these sources is, does it just seem like change is happening faster than ever, or, is it actually true?
Well, the sources strongly suggest it's true. I mean, one of the most striking points is just the speed of user adoption. It's
Right, like that chart you found comparing AI user growth to the internet. Is that what you mean?
precisely that one, yeah. The data on let's say, a leading US-based LLM, a large language model like the engine behind ChatGPT,
Uh-huh.
it shows it reached 90% of its current user base outside North America in what, just 3 years?
Wow.
Compare that to the internet. It took 23 years for the internet to get that kind of global reach.
23 years versus 3. I mean, that's a massive difference right
It
there.
really is.
And the sources, they mentioned this AI user plus usage plus CapEx growth being unprecedented. So beyond just signing up, what kind of usage and CapEx growth are we actually talking about here?
Yeah, good question. We see indicators like the number of developers in NVIDIA's ecosystem. They make those crucial AI chips, the PPUs and ASICs.
Right, the builders.
Exactly. That developer community grew from about 1 million to 6 million people in just 7 years. That's a, plus 6x increase. Huge.
So it's not just users flocking in, but the people actually building with this stuff too.
Yes, precisely. And then there's the investment behind it all. The sources track the capital expenditure, the capex, from the big six U.S. tech companies.
Okay.
That spending grew by, get this, 63% year over year, hitting $212 billion. I mean, the scale and the sheer speed of that growth, it really does seem unprecedented compared to, say, the dot-com boom or other tech shifts.
Okay, that definitely sets the stage. The pace is, well, bananas, as you said.
Yeah.
But why? Why is it happening so incredibly fast this time?
Hmm.
What's the engine?
So this is where the sources really dig into the idea that AI technology isn't just improving like step by step. It's compounding.
Compounding. Okay, so like multiple things accelerating all at once,
Mhm.
faster chips and smarter software maybe?
Exactly. That's a great way to put it. The sources show these really rapid annual growth rates happening simultaneously. You've got training compute for AI models, the sheer processing power needed to teach them.
Uh-huh.
That's growing 360% per year. Then the gains from just better algorithms, smarter ways of teaching the AI, that adds another 200% per year performance improvement.
So the hardware gets faster and the methods get better too.
Right. And the performance of the leading AI supercomputers themselves, improving 150% per year. Plus, just the number of powerful, large-scale AI models being released is growing 167% per year.
Wow. So it's like you're stacking multiple layers of exponential growth right on top of each other.
That's a really good analogy. And the source material also points to the public launch of ChatGPT back in November 2022 as AI's iPhone moment.
Ah, okay. The moment it became accessible.
Exactly. It marked this new era of what they call active plus digital plus generative delivery for knowledge, moving beyond the printing press, which was static and physical, and the internet, which was active and digital,
Okay.
to something that actively generates knowledge for you. And that accessibility, that just fueled that massive initial adoption wave we were just talking about.
Got it. So the engine is this compounding tech, making AI faster, smarter, cheaper, more accessible. So what can this super accelerated AI actually do now? What do the sources say about its capabilities today?
Well, we're seeing AI model performance converge incredibly rapidly with human levels and, in some specific areas, actually surpassing them.
You mean like on benchmark tests and things like
Yes,
that?
exactly. The sources mention the MMLU benchmark. It tests knowledge across like 57 different subjects: history, math, law.
Right.
And the average accuracy of the top AI models hit 89.8% in 2024. Now, that score is widely seen as the general benchmark for human expert performance on that same test.
89.8%.
Yes.
That's incredibly fast progress, considering where these models were just a couple of years back.
It really is.
What about, just talking to it,
Yeah.
mimicking humans in conversation? The sources bring up the Turing test, right?
Yeah, and this is a fascinating detail from the sources. There is a Turing test study cited from March 2025
Okay.
where 73% of the human testers actually mistook the AI's responses for being human. 73%.
Wow.
And one participant was even quoted describing the AI as having human vibes. So it shows this increasing realism, this naturalness in conversation.
That's pretty wild.
Yeah.
And beyond just text, the sources talk quite a bit about multimodality dealing with images, audio, video.
Yes, multimodal AI models are a really key development discussed. They can process and generate content across all these different formats.
So they can see and hear, not just read and write.
Pretty much, yeah. And the number of these large-scale multimodal models being released, it increased by, wait for it, 1,150% over just 2 years.
Whoa. Okay, so that's clearly a huge focus area.
Definitely indicates a rapid shift towards that capability.
And then the sources talk about this new class of AI emerging, AI agents. What's the deal with those?
Okay, this is where it gets really interesting, according to the sources. They describe agents as intelligent, sort of long-running processes that can actually do work. They're evolving beyond just giving you a quick chat response.
Doing work. How so?
Well, they're becoming an action layer. They can understand a goal, break it down, use tools, interact with websites, maybe even make decisions over time to get something done for you.
Ah, so they're not just information retrievers, they're becoming like task doers.
That's a good way to put it. And you can see the interest just spiking. Global Google searches for AI agent apparently rose by over 1,000%, 1,088% to be exact, over just 16 months.
Okay, so people are definitely searching to this. Are companies launching them?
Absolutely. The sources mention incumbents are already rolling out agent capabilities, things like Salesforce Agentforce or Anthropic's Claude 3.5, getting the ability to actually use a computer interface. It signals a big shift.
From chat to action. Okay.
Less like a search box, maybe more like a proactive assistant.
Right. Now, all this power, all these capabilities, it obviously requires some serious infrastructure. The sources really hammer home that CapEx point, the capital expenditure.
Yeah, this is a critical piece of the puzzle. The sources frame this current AI CapEx wave as like a whole new stage of industrialization.
Like electricity or the internet build-out.
Kind of, yeah,
But
but driven by computation and intelligence needs. It's about building the foundational layer for this new era.
And the big six tech companies, they're the ones leading the charge here, building the factories, so to speak.
Yes, their CapEx accelerated massively. Remember that plus 63% year-over-year growth we mentioned. A huge part of that is pouring into data centers.
Right.
And the sources show that in U.S. alone, the value of data center construction has been growing at 49% annually for the past 2 years.
49% annually. And they're building them incredibly quickly, too, right? There was an example.
Yes, the example given is xAI's Colossus supercomputer. That data center was reportedly built in just 122 days,
Wow.
which the sources described as superhuman speed for that kind of major construction project.
Okay, so massive investment, breakneck construction speed.
Yeah.
What about the chips inside those data centers, the GPUs, the ASICs?
Still absolutely foundational. The sources highlight NVIDIA as a key beneficiary, naturally. Their data center revenue alone apparently represented something like 25% and rising of all global data center capex in 2024.
25%. That's huge.
It is. But it's not just NVIDIA. Other big players like Google with their TPUs and Amazon with their training chips, they're also developing their own custom silicon. Everyone's chasing better price performance for AI workloads. But there's a big but here that the sources flag.
Right.
There's, quote, no AI without energy. All these data centers, they consume enormous amounts of electricity. And that consumption is growing really, really rapidly.
Right, raising questions about the grid's ability to keep up.
Exactly. And it aligns perfectly with this economic concept called Jevons paradox, the idea that when using a resource gets more efficient, like computation gets cheaper, we don't use less of it.
We actually use more.
We use way more because the new efficiency unlocks entirely new applications and scales of use we couldn't imagine before. So cheaper AI compute drives more energy demand, not less. It's a real constraint to watch.
That energy piece is definitely critical. Okay, so building the infrastructure is wildly expensive. But what about the costs of actually using the AI models once they're built and trained?
Yeah, the sources point to this really interesting dynamic. The cost to train these huge models, it's high and it's still rising. We're talking maybe $100 million now, potentially $1 billion soon for the absolute cutting edge ones.
$1 billion to train one model. Wow.
Yeah. But the cost of inference, that's actually using the trained model to get an answer or generate something that costs per token or per output, is falling, and falling quite rapidly.
Okay, so expensive to build, cheaper to run, basically.
Exactly. And this is described as a kind of perpetual aha moment in technology, right? Costs fall, performance goes up, usage explodes.
So falling inference cost is good for users, good for developers.
It's a huge gift. It makes AI much more accessible, drives adoption, lets people build new things on top of it.
But how does that affect the companies that made the models? If using them gets cheaper and cheaper,
hmm
how do they, you know, make their money back?
And that's where the sources introduce what they call AI monetization threats. Because while falling costs are great for the ecosystem, it raises real questions about monetization and profits for the model providers themselves, because the competition is just getting incredibly fierce.
Okay, what kind of competition are we talking about? Who are they competing with?
Well, several fronts, according to the sources. First, you've got other major companies with their own leading LLMs fighting head to head.
Right.
Then there's the huge momentum behind open source models. These are powerful models that anyone can download, modify, run themselves, often at much lower costs, sometimes even free. That puts massive pressure on proprietary models.
Okay, open source is a big factor. And the other one you mentioned?
China. The sources frame this very clearly as an AI space race with
Yeah.
potentially massive geopolitical implications.
A space race? Well,
Yeah. China has poured resources into AI and accelerated its capabilities incredibly quickly in strategic areas. Their LLMs, like Alibaba's Qwen or Baidu's Ernie, they're benchmarking really competitively now, sometimes matching or even beating Western models on specific tasks. And critically, often at a fraction of the cost. Like the sources mentioned Baidu Ernie 4.5 Turbo being priced at just 0.2% of GPT 4.5's cost.
0.2%.
Yeah.
That's basically giving it away compared to the competition.
It's incredibly aggressive pricing. And China also leads the world in installing industrial robots, showing their focus isn't just language models, it's AI across the board, especially in manufacturing.
Okay, so intense competition, falling usage costs, geopolitical races. It sounds like a tough market. How are companies actually making money with AI then? Show me the money, as they say.
Right. Well, the sources point to several monetization models that are emerging and working, both for new startups and for the big incumbents.
Okay, give us some examples from the sources. Let's start with the new players, the startups.
Sure. So companies like Anthropic, one of the big LLM competitors, their API and generative search revenue apparently saw explosive growth, like 20x growth to a $2 billion annual run rate in just 18 months.
20x in 18 months. That's incredible.
It's stunning growth. Or Glean, focusing on AI agents for enterprise search. They reportedly grew their annual run rate 10x, hitting $100 million in 24 months.
Okay, so the core model providers and enterprise search are seeing traction. What about AI applied to specific industries?
Yeah, this is where you see some really specialized AI software taking off incredibly quickly. The sources give several examples. AnySphere Cursor, that's an AI code editor for software engineers,
Uh-huh.
went from $1 million to $300 million AR, or annual recurring revenue in 25 months.
Wow.
A Bridge in healthcare, summarizing patient visits, $50 million to $117 million ARR in just 5 months. Harvey for legal workflows, $10 million to $70 million ARR in 15 months. Decagon for customer service, $1 million to $10 million ARR in just 1 year. AlphaSense for financial research grew from around $150 million to maybe $420 million ARR in 2 years.
Those growth rates are just, they're astronomical. It shows the demand is definitely there for tools that solve specific problems.
Absolutely. It's not just theoretical value. Companies are paying serious money for these targeted AI solutions.
Okay, so that's the newer entrants. What about the big established tech companies? The Googles, Microsofts, Metas, they've got billions of users already. How are they monetizing AI?
Well, they're doing exactly what you'd expect, rapidly rolling out AI features across their existing massive platforms.
Embedding it everywhere.
Pretty much. Meta AI, integrated into WhatsApp, Messenger, Instagram, reached almost 1 billion monthly active users very quickly. Microsoft Copilot, built into Office, Windows, etc. Billions of cumulative chats reported. Google rolling out Gemini and AI overviews to their huge search and workspace user bases. And it's translating to revenue. The sources highlight that Microsoft's AI business by itself was estimated to have surpassed a $13 billion annual revenue run rate as of early 2025.
13 billion.
Yeah, and that was up 175% year over year. So the incumbents are absolutely monetizing AI at scale already by leveraging those enormous existing customer relationships and platforms.
Okay, so AI is clearly transforming software, digital services, how businesses operate online. But the sources also spend time talking about it moving beyond the screen into
Yeah.
the physical world.
Yes, this is another key trend. They pull out the rise of what they call physical agents.
Mm.
AI isn't just analyzing data, it's being embedded in things that move and interact with the real world.
You mean like self-driving cars and things like that?
That's a perfect example. The sources track Tesla's cumulative miles driven on their fully self-driven system. It apparently increased something like 100x over just 33 months.
100x.
And Waymo, the Google unit. They reportedly captured 27% of the ride-sharing market in San Francisco in only 20 months of operation there. That's real market share, real-world usage.
And it's not just cars, right? It's broader than that.
Oh, yeah, much broader.
Yeah.
Companies like Applied Intuition are providing the AI software, the vehicle intelligence, for autonomous systems in trucking, construction, even defense, not just passenger cars.
Okay.
And then you have companies like Endural growing rapidly by selling AI-powered autonomous defense systems, drones and the like, to the U.S. military.
Right.
And even in industries you might not immediately think of, like resource exploration, cobalt metals using AI to help find mineral deposits, or agriculture carbon robotics using AI-powered machines to precisely zap weeds, covering over 230,000 acres already. So the core idea the sources put forward is that AI is turning physical capital assets, cars, tractors, machines, defense hardware, into essentially software endpoints. The intelligence becomes kinetic. It acts in the physical world.
Turning hardware into software endpoints.
Yeah.
That's an interesting way to think about it. And were there other new frontiers mentioned, like scientific discovery?
Yes, protein sequencing was given as a really potent example. The size of AI models used just for that task is growing 290% annually.
Okay.
And the sources specifically mentioned AlphaFold from Google DeepMind. By using AI, particularly with synthetically generated data, it expanded the coverage of known protein structures by a factor of 1,000x.
1,000 times. That must be hugely accelerating research in biology and medicine.
Absolutely. It's a prime example of AI tackling fundamental scientific challenges.
Okay, shifting gears just slightly towards the end here. The sources touch on AI's global reach and how it might fundamentally change the experience for people coming online for the very first time.
Yeah, this is a really fascinating point with potentially huge implications. You've got satellite internet like Starlink expanding global connectivity.
Right, bringing access to places that never had it.
Exactly. And there are still about 2.6 billion people, that's 32%, almost a third of the world, who aren't online today. The sources speculate that when these people do get access, their first, maybe primary interaction with the internet might not be through a web browser or a search bar like we're used to.
So they might interact mainly through AI, like an AI assistant.
Precisely. They might experience an agent-first internet. Their main interface could be an AI agent that helps them find information, access services, communicate, effectively skipping the whole browser search paradigm that dominated the first few decades of the web.
Imagine that. That could totally reshape, who the dominant tech players are globally if the interface itself changes that dramatically for billions of new users.
It really could. It disrupts existing hierarchies.
Okay, and finally, let's tackle the big one, the impact on jobs and work. The sources seem pretty direct about this.
They are. They state very clearly that AI's impact on work evolution is real plus rapid. And they back it up with data. Like this one statistic, between 2018 and early 2025, job postings in the USA that specifically mentioned AI skills increased by 448%.
440%. Wow. And what happened to other tech jobs?
During that exact same period, non-AI related IT job postings actually decreased by 9%.
Okay, so that's not just growth in AI jobs. It's a clear shift in demand within the tech sector itself.
A very significant shift. And it's not just about hiring. Companies are seeing real productivity gains from using AI internally.
Like what?
Well, the sources cite studies showing things like customer support agents using AI tools boosting their productivity by 14%. Scientists using AI seeing a 31% increase. Companies are actively adopting AI because they expect these kinds of improvements.
And you see CEOs like a Duolingo or Shopify talking publicly about becoming AI-first organizations.
That's right. The sources include quotes or references to memos where these leaders are saying AI is already changing how work gets done, how fast content can be created, how processes are fundamentally being rethought.
Duolingo even said AI use would be part of hiring and performance reviews.
Yes, indicating how deeply integrated it's becoming into their actual operations and expectations for employees. And there's a quote in the sources from one CEO that I think really encapsulates this shift well. They said basically, you're not going to lose your job to an AI.
Uh-huh.
You're going to lose your job to somebody who uses AI.
Right. It's about augmentation, using it as a tool.
Exactly. It frames AI as this powerful productivity lever, and the pressure is on individuals and companies to learn how to use it effectively.
Okay, so let's try and wrap this up. Looking back at this deep dive into your sources,
hmm
wow, we've seen AI accelerating at this just, frankly, unprecedented pace.
Yeah, driven by that compounding effect, multiple technologies all getting better, faster, exponentially all at once.
Fueled by absolutely massive and incredibly rapid investment in infrastructure, that whole CapEx wave, building out a new computational age.
Right, and we saw how AI capabilities are not just improving, but rapidly hitting human benchmarks, becoming multimodal, seeing, hearing, creating, and evolving into these potentially autonomous agents that can actually do things.
Then there's the whole economic side, the high training costs but falling usage costs, driving adoption but creating monetization challenges.
Exactly. And that intense competition between big tech, open source, and crucially, the US versus China dynamic framed as a new kind of space race.
And finally, we saw clear evidence from the sources that this isn't just future talk. AI is already having a real and rapid impact. We see it in the hypergrowth of AI startups, the integration by
The
incumbents,
move into the physical world with cars, robots, defense systems.
and fundamentally reshaping the job market, demanding new skills while potentially changing how billions of people first experience the internet.
Yeah, the sources really make a compelling case that imagining a world without AI pretty soon might feel as strange as imagining a world without the internet feels to us right now.
So here's maybe a final thought for you, the listener, to chew on after all this. Given this speed, this intensity, this clear evidence of AI becoming foundational, what does this mean for you in the next, say, 1 to 2 years? How might you start thinking about using AI not just as a novelty, but as that tool, that productivity lever, to make sure you're the one using it, not the one being left behind by someone who is?
And maybe on a broader level, how do we as a society navigate this? How do we balance this incredible accelerating innovation with the kind of thoughtful leadership and guardrails needed to manage the risks? Risks that even profound thinkers like Stephen Hawking, who's quoted in some of these sources, warned us about.
Powerful questions, definitely raised by the material you brought us. Thank you so much for walking us through this tack today. We really hope this deep dive was valuable for you.